Hello everyone, welcome to the channel Upgraded Than Yesterday. Today we are going to learn about autoboxing and unboxing with examples. Also we will learn about what is the need of it, the places where it happens and its pitfalls with real life examples. What is autoboxing? Autoboxing in Java is the automatic conversion of primitive type like int, double, long, etc. into its corresponding wrapper object like integer, double, long, etc. Autoboxing was introduced in Java 5. Look at the example. The primitive int variable x is holding a value 10. Then this x is assigned to a wrapper integer variable obj. On printing the variable obj, it will print the value 10. Because the primitive int value is autoboxed into the wrapper integer during the assignment of x to the variable obj. What is unboxing? Unboxing in Java is just the opposite of autoboxing. It is used to convert wrapper object like integer, double, long, etc. to the corresponding primitive type like int, double, long, etc. The autoboxing and unboxing was introduced in Java 5. Look at the example. The wrapper integer variable obj is assigned with an integer object with a value 10. This object is assigned to the primitive int variable x. On printing the variable x, it will print the value 10 because the wrapper integer object is unboxed to the primitive int. Why is autoboxing needed? In Java, the collections, maps, generics, etc. only works with object. It does not support primitives. Let's understand why it does not support primitives. In Java, the collections, maps, etc. are built on the top of generics. The generics internally works on the concept called type eraser. Suppose you have a list of integer. During runtime, the JVM will convert the list of integer into a list of object. That means every generic type has to be a child of object class. But since primitives are not a child of object class, so it does not support primitives. So to support the primitives, the autoboxing is needed. Look at the example. We have a list of integer and added two values to it. One is a primitive value 10 which got autoboxed and another is integer object with a value 10. Here we have seen without autoboxing, a programmer has to write the code to convert the primitive into its corresponding wrapper object manually. The autoboxing removes this manual work and does the conversion automatically. Let's understand where does autoboxing and unboxing happens. Let's start with autoboxing. There are multiple places where autoboxing happens. Here I have listed a few. Autoboxing happens during assignments of a primitive value to a wrapper type. For example, integer a is equal to 10. Here the primitive value 10 is autoboxed internally. Autoboxing happens during passing a primitive to a method which is expecting a wrapper type. For example, look at the code. Although the method print accepts wrapper integer type, but it is allowed to call this method by passing a primitive value. Here the primitive value will get autoboxed internally. Autoboxing happens during returning a primitive value from a method which returns a wrapper type. For example, the get method supposed to return a wrapper type integer, but it is returning a primitive value 10. This primitive value 10 is autoboxed internally. Autoboxing happens in arithmetic operations or ternary operations if the variable is wrapper type and assigned value is primitive type. For example, look at the code. X is a type of wrapper type integer, but based on a condition, a primitive value 10 is getting assigned and internally this int value is getting autoboxed. Autoboxing happens while adding a primitive to a collection. For example, here we are adding a primitive value 10 to a list of integer. While adding the primitive value, it will get autoboxed internally. Autoboxing happens while adding a key or a value to a map. For example, look at the code. The map key is defined as wrapper integer, but a primitive value 10 is used as a key. This end value is autoboxed internally. Now let's understand where unboxing happens. Unboxing happens during the assignments of a wrapper type to a primitive type. For example, look at the code. The primitive int variable is assigned with an wrapper integer object. This is allowed as unboxing of a value 10 will happen internally. Unboxing happens during passing a variable type to a method which is expecting a primitive type. For example, look at the code. Although the method print accepts primitive int type, but it is allowed to call this method by passing a wrapper integer object. Here the wrapper integer value will get unboxed internally. Unboxing happens during returning a wrapper type from a method which returns a primitive type. For example, the get method supposed to return a primitive int type, but it is returning a wrapper integer object with a value 10. This is allowed because the wrapper integer object will get unboxed internally. Unboxing happens in arithmetic operations or ternary operations if the variable is primitive type and assigned value is wrapper type. For example, look at the code. X is a type of primitive type, but based on a condition, a wrapper integer object of value 10 is getting assigned. This is allowed because wrapper integer object will get unboxed internally. Unboxing happens during comparison with primitives. For example, look at the code. The wrapper variable x is getting compared with a primitive value 10. Here the value of x will get unboxed first before comparison. Unboxing happens if the wrapper type is used to find an index of an array. For example, the variable index is type of wrapper integer, which is used to find the index of an array. This is allowed because the wrapper integer object will get unboxed internally. Unboxing happens if the wrapper type is used in switch case expression. It unboxes the wrapper type to corresponding primitives to be used in switch cases. Here the value of x will get unboxed first before used in switch case. Let's learn about the pitfalls of autoboxing. Autoboxing creates a lot of objects in the heap memory. If the number falls outside of cache range, that is -127 to +128, then it always creates a new object although the same number is assigned. For example, look at the code. For both variable a and b, there will be two objects created in the heap, although the same number 200 is assigned to both. Now just imagine you are adding 1 million primitive values to a list. There will be 1 million objects created in the heap. Second pitfall. Autoboxing in varargs happens silently, so a program may behave unexpectedly. Look at the example. The method print, which accepts a vararg of object type, it is called by passing primitive values. Although the values are primitive, the JVM won't complain anything and it will silently convert the primitives to its wrapper types and will execute the method. Since this conversion is happening silently, so the program might behave unexpectedly. Third pitfall. In arithmetic operation, autoboxing hides the types you are working with. Suppose we have a, b, c and d integer type wrapper variables and these are used in an arithmetic operation as shown. Here it looks like the arithmetic operations are happening on the object, but actually it is not. The JVM will unbox wrapper value to primitive and then it will perform the arithmetic operation. At the end, the result will get autoboxed to the wrapper type. This is a pitfall because operation supposed to happen on object, but it hides the types during internal execution. Fourth pitfall. Autoboxing is skipped for overloaded methods. Look at the code. There are two overloaded methods, one print method with primitive long type and another print method with wrapper integer type. Now calling the print method by passing a primitive value 10, it's supposed to execute the print method with the wrapper integer type after autoboxing, but it has executed the print method with the primitive long type because the widening has more priority than autoboxing. Since autoboxing didn't work here as expected and ended up executing a wrong method, which is dangerous and may cause system failure. Fifth pitfall. For the same autobox values, the contains and equals method of a collection may behave unexpectedly. Look at the code. The list of long is populated with a long value 100. Now upon calling the list.contains with primitive value 100, it will return false, but it returns true when it is called with a long value 100. Here although the values are same, but JVM always autobox the primitive int value to wrapper integer type. So to autobox a primitive value to long type, there is a need of adding a suffix letter L with the primitive number. It is very tricky and may introduce bug in the code. Now let's understand the pitfalls of unboxing. First pitfall is NullPointerException. This is one of the dangerous exception because it causes system failure. Look at the code. Since a primitive value can't be assigned a null value directly, so we have created a wrapper object with null value and that object is assigned to the primitive. Here JVM won't complain anything at compile time, but it will throw a NullPointerException at runtime. Second pitfall. The value comparison using equals to operator gives wrong results if the values are outside of cache range. Look at the code. A and B both are holding the same value 100. So when A is compared to B using equals to operator, it printed true. This is because the number 100 falls under the cache range. So far so good. Now let's take another pair of variables C and D and assign the value 200 to both and compare. This time it gives false. This is because the number 200 falls outside the cache range. This kind of issue is very hard to debug. Third pitfall. The overloaded method remove of list collection behaves very differently with primitive and wrapper. Look at the code. There is a list of integer populated with values 1, 2, 3, 4, 5 and 6. When list.remove is called with the primitive value 2, it removes the value at index 2, which is the value 3. But when the list.remove is called with wrapper object with value 2, it removes the first occurrence of value 2 from the list. These two overloaded methods are very confusing and behaves very differently. Fourth pitfall. Unboxing changes behavior of equals method. Look at the example. The integer wrapper variable A is assigned with a value 1000 and also the primitive long variable B is assigned with a value 1000. When both are compared using equals method, it returns false, but when same is compared using equals to operator, it prints true. This is because for equals method, primitive long value is autoboxed to wrapper type long and hence it returns false during object comparison. At the end, please go through this chart. For every primitive, there is a wrapper class mentioned. That's all for this video. I hope you liked this video and were able to learn something new. Until the next video, take care, bye bye and thank you for staying with me.